Alright, so we have just reviewed some general concepts, and next let's have a look at the first types of functions, which is linear functions, or we know the graph of linear functions just lines, right? So we also call this lines in two-dimensional space. Okay, so the most important properties of a line is its slope. I think you should have already heard of this, right? And slope is sometimes called gradient. The slope of a line in the plane containing the x and y axis is generally represented by the letter m. And slope is defined in this way, assuming 2 points, which are A and B, whose coordinates are x1, y1, and x2, y2. Of course, if x1 does not equal x2, we can define the slope of line AB as follows, which is delta y over delta x, right? Are you clear? No? Okay. I'll explain this a little bit. So this is a definition of a slope of a line, which is defined as delta y over delta x. What is delta y? Delta y is the difference between these two y coordinates, and delta x is the difference between these two x coordinates. And if x1 equals x2, actually this line is parallel to y-axis, right? In that case, we do not have a slope, or slope is undefined. So there are 4 different scenarios for a given line. On top left, a line is increasing if it goes up from left to right. Then in that case, the slope is positive, right? In this case, m is positive, which is shown here on top left. Line is decreasing if it goes down from left to right. The slope is negative, which is shown here in this case. And of course, if a line is horizontal, the slope is 0, right? Because y2 equals y1. And for the last case, if the line is vertical, then the slope is undefined, because in that case, x1 equals x2. We cannot use 0 as a denominator, right? So in that case, m is undefined. Are you clear? Okay, next. The intercepts of a line, which includes both x-intercept and y-intercept. First, we know the intersection point between the given line and the y-axis is called a y-intercept, usually denoted by the point with coordinate 0, b. It's also okay if you say the y-intercept is b, because y-intercept implies that the x coordinate is 0. So you could also say y-intercept is b. Or more strictly, that's actually a point with coordinate 0, b. And if an equation of a line is given, we can simply let x equal 0 to find the value of b, right? And also note that if the line is parallel to y-axis, then the y-intercept does not exist. Secondly, the intersection point between the given line and x-axis is called x-intercept. And again, you could simply let y equal 0 to solve for x to find the value of all the x-intercept, right? This is how we can get this x-intercept and y-intercept. So next, let's have a look at the equations of lines. How do we express lines? The most commonly used equation for a line is a linear function, right? Which is also called slope-intercept form. If the slope of line is m and y-intercept of line is 0, b, then we could express this line as y equals mx plus b, right? Again, I'm not gonna prove this for you. If you are interested, you could let me know after this class. And the next type of function for a line is called general form. Any line can be expressed in this form: ax plus by plus c equals 0. Or sometimes we move c to the other side. Ax plus by equals c. Doesn't matter if you use positive c or negative c, because c is an arbitrary real number, right? So such a equation is called the general form of a line, because every line, including the line without the slope, can also be expressed in this form, right? For example, if a line is vertical, we do not have a slope for this line, but it still can be expressed as x equals, for example, k, right? This is also a line, perpendicular to x-axis or parallel to y-axis, as long as a and b cannot be 0 at the same time. If they are zeros at the same time, you simply end up with c equals 0. And this is not necessarily true. We don't have any variables in that case. So just ensure a and b cannot be 0 at the same time. Usually we'll use this equation to denote a and b cannot be the same time. So this is equivalent with the English expression like this. The left side is just the mathematical language, and the right side is our natural language, right? And in other words, this line equation, this linear equation, describes a relationship between x and y. Any point x, y that satisfies this relationship is on the same line. Okay? And this is the second type of equation for a line. And the third type of line is called point-slope form, which states that if you know the slope of a line is m, and you also know the line passes through a given point, which is x0, y0, or sometimes read as x0, y0, then we know the equation of this line can be expressed in this way: y minus y0 equals m times x minus x0. Did you get it? Okay. Then the last type of commonly used equation for a line is called two-intercept form, which means if you know the x-intercept of a line is a, 0, and y-intercept of a line is 0, b, then we could express the equation of this line directly as x over a plus y over b equals 1. All right, let me explain why this is true. So suppose we have a line and x-intercept is a, 0, y-intercept is 0b. So this point is 0b, right? So first of all, we can calculate its slope, which is delta y over delta x, which is 0 minus b over a minus 0, which gives us negative b over a. And if you know the slope, and we also know the y-intercept, which is 0b. So the slope intercept form of this line is y equals negative b over a x plus b, right? Then because a is not 0, b is not 0, we can multiply both sides using a first. That equals ay equals negative bx plus ab. Then move bx to the other side. We have ay plus bx equals ab, which is, if we divide both sides using ab, then we have x over a plus y over b equals ab, right? Equals 1, right? So that's why if you know two intercepts of a line, you can express this line in this form, as long as a is not 0 and b is not 0, right? Any questions? No? Okay. Then let's have a look at some other trivial concepts about lines. So first, parallel and perpendicular lines. If two lines are parallel, this statement is equivalent to the following two cases. First, both of their slopes do not exist. For example, they could end up like this. You have two vertical lines. These two lines are parallel with each other. Both of them do not have slopes, right? And if both of their slopes exist, then their slopes must be equal, right? Did you get it? Two parallel lines means they could both do not have slopes, or if both of them have slopes, their slopes must be equal. Okay, I will not prove this for you, and if you are interested, you can refer to some other references. And then let's talk about perpendicular lines. Perpendicular lines means if two lines are perpendicular, that is equivalent to either of these two cases. So again, first case corresponds to that. One line is parallel to x-axis, the other line is parallel to y-axis, and at least one of them do not have slope, right? Or if both of their slope exists, something like that, we know the product of their slope must equal -1, right? So the proof of this involves the use of trigonometry. Again, when we learn trigonometry, we can prove this easier. All right, next, if you want to find the point of intersection between two lines, usually we'll combine their equations together and find a possible solution, right? If you could find a solution, then that means, if you could find a unique solution, that means they intersect at exactly one point. Otherwise, if you find infinite number of solutions, this means these two lines are actually the same line. Or in other cases, if you have a pair of parallel lines, there's no solution, right? So simply combine their equations to find the point of intersections. Okay, now let's have a look at some examples to illustrate the concept. Okay, first example, what is the slope of a line passing through these two given points? Can you recall the definition of slopes? Okay, I'll write it here for you. So slope m is defined as delta y over delta x, right? So this is, you could either use this point as the first point or this point as first point. Just make sure the order of these points line up together. So if you use 5 minus -5, you should also use -3 minus 2, right? You should follow the same order for both x and y's. So for example, you could use 5 minus -5, and then you must use -3 minus 2 correspondingly. And this gives us 10 here and -5 here. Then we know the slope of this line is -2, right? And now you want to find the equation of this line. So this time we have the slope, we have a given point. You could use either the first point or the second point, right? Suppose we use the first point, then we can write the line's equation in point-slope form, right? So we know the equation of this line is y minus the given y equals slope -2 times x minus the given x, which is equivalent to y minus 5 equals -2x minus 3. Sorry, minus 6. And usually we'll convert it to slope-intercept form. So y equals -2x minus 1, right? That's the equation of the line, right? Okay, so if no questions, let's see the next one. What is the equation of the line that passes through the point and has a slope of -1/4? So here you should be able to write the equation of this line very quickly, right? Because we already know the slope and a given point. So we know the slope point form of this line is y minus the given y equals slope -1/4 times x minus the given x, which is plus 3, right? Minus 3 gives you plus. So that's equivalent to y equals -1/4 x minus 3/4 then plus 1. And usually we'll convert it to slope-intercept form, which is y equals -1/4 x then plus 1/4, right? That's the equation of this line. Okay, just make sure you choose appropriate form of equation when you are given the corresponding information. That'll save you a lot of time. But eventually, usually we convert it to either general form or slope-intercept form. These are the two commonly used forms of lines. Okay, and then let's have a look at one last example of lines, and then we can take a break. Consider these two questions. I'll give you some time to solve them, and we'll have a look at the solution after that. Okay. Okay, let's have a look at the solution together. So for the first question, if we know the desired line is parallel to the given line here, then we know the slope of the desired line, right? So first of all, let's suppose the desired line is, well, apparently it has a slope because the slope of this line is not 0. So we can let this line be y equals mx plus b, right? And let's find the slope of this line here. So usually we can convert that to a slope-intercept form to find a slope, which is 7y equals 2x minus 4, which is equivalent to y equals 2/7x minus 4/7, right? And we know the desired line must have the same slope with this line here, which means m equals 2/7, right? And therefore we know y equals 2/7 plus b. Also, this line crosses the point 2, 1. So we can insert 2, 1 into that line. When x, sorry, I lost the x here. When x equals 2, y equals 1. So we can solve b. So this means b equals 3/7. Therefore, we know the desired line is y equals 2/7 x plus 3/7, right? You get it? How about the second question? What is the x-intercept of the line through -3, 4 that is perpendicular to the graph of this line? Okay, first of all, we know if two lines are perpendicular to each other, if both of their slopes exist, the product of these two slopes should equal -1, right? So first of all, let's convert the equation of this line to slope-intercept form, which is 2y equals x minus 7, which means y equals 1/2x minus 7/2. And we could let the desired line be, well, if you know the slope is 1/2 here, you can also directly let the desired line be y equals -2x plus b, because we know -2 times 1/2 equals -1, right? And then it crosses this point. -3, 4. Therefore, we can insert this point into that equation. Y equals 4 So 4 equals -2, while x equals -3 plus b. And therefore b can be solved to be -2. And therefore we know the desired line. Okay, I will not write all of the statement here. Just to make sure you write the full statement here, okay? Therefore the desired line has the equation y equals -x minus 2, right? Do you get it? Okay, so that's the second key point in topic 1. You can take a short break, and after that we'll have a look at the third key point, quadratic functions, okay?